Welcome to SmartCertify. In this training, we will cover CISA Domain 3, Information Systems Acquisition, Development, and Implementation. In this section, we'll cover how systems are selected, built, and implemented while ensuring they meet business goals and are properly controlled. Let's begin. In this free training series, you'll learn everything you need to master each domain. Need expert study materials? Just send us an email at smartcertifytraining@gmail.com. And for real practice, access our 1,800 Question exam set using the Etsy link in the description. Many auditors have passed on their very first try with this exact approach, and now it's your turn. In this section, we'll begin with Topic 1, Project Governance and Management, laying the foundation for how projects are aligned, structured, and overseen. The upcoming videos will cover the next topics: business case and feasibility analysis, system development and design, and control identification and design. Please continue with those to complete the full learning module. In this section, we'll explore how governance and management work together to ensure project success and alignment with business goals. I'd like to walk you through how project governance and management work hand in hand to support enterprise objectives. Let's keep this practical and easy to follow. In most organizations, there's rarely just one project running at a time. Usually, there are several, sometimes dozens, all moving at once. That's why companies often set up a project portfolio or program management structure. The goal is simple: to make sure every project is working toward the same big-picture business goals, to manage shared risks, and to avoid wasting time and resources. But just having multiple projects isn't enough. Each project needs structured governance. This means having clear roles, decision-making processes, policies, and controls in place. It also means regularly checking if the project is still delivering the value it promised in the original business case. Now, when we think of project management, it's easy to focus only on deadlines, budgets, and deliverables. And yes, those are essential. But successful project management also depends on softer skills like leadership, resolving conflicts, keeping the team motivated, and communicating clearly. And let's not forget the bigger picture. Internal politics, stakeholder expectations, even ethical considerations, these all play a role. In large transformation programs, we often bring in third-party providers, for example, to implement SAP or move to infrastructure as a service, IaaS. But here's the catch: their solutions must fit the business, not the other way around. We shouldn't accept a one-size-fits-all approach just because it's easier to implement. And finally, let's not forget the IS auditor's role. As auditors, we're there to ensure that separation of duties is respected, controls and system development are in place, and that the organization is following its chosen project management methodology correctly. Let's now take a quick look at how enterprises structure their projects, because the way a project is organized can have a big impact on its success. There are typically three common structures. First one is functional structured organization. In this model, authority stays with the functional managers, such as heads of departments. The project manager acts more like a coordinator and usually has limited authority over decisions and resources. This setup is common in traditional organizations where departments work in silos. For example, imagine an IT upgrade taking place within the finance department. The finance director is in charge, while the IT team simply supports the project. Second one is project structured organization. Here, it's the project manager who has full control over the budget, the people, and the decisions. This is the preferred setup for large, high-risk, or time-critical projects where fast and clear decision-making is essential. For instance, think of a company launching a brand new CRM system. A dedicated team is formed, and the project manager runs the show, no need to go through department heads for every decision. Third one is matrix structured organization. And finally, we have the matrix structure, which is a blend of both approaches. Here, authority is shared between the project manager and the functional managers. It's a flexible model, but if responsibilities aren't clearly defined, it can lead to confusion or conflict. A good example is an ERP implementation. HR and finance departments provide their staff to the project team, but the project manager handles the schedule and coordination across departments. Each of these models has pros and cons. and as an IS auditor, it's useful to recognize which structure is in place because it affects decision-making, communication, and ultimately, project risk. Let's talk about the key roles in a successful project. Every successful project depends on one thing: clearly defined roles and responsibilities. Let's walk through each of the main ones and what they do. Project Steering Committee. This group provides overall strategic direction. It usually includes senior leaders from departments affected by the project. They review progress, resolve major conflicts, and ensure the project is aligned with business goals. Project Sponsor. The sponsor is like the owner of the project. They secure funding, work closely with the project manager, and make sure the project delivers real business value. Project Manager. The project manager is the engine room. They handle the daily operations scope, scheduling, budget, communication, and risk. They're also the key link between the team and the sponsor. User management and project team. These are the people who know what the system needs to do. They provide requirements, help with testing and training, and approve final outputs. Their involvement ensures the solution actually works for end users. QA team, quality assurance. QA makes sure the project meets quality standards. They review deliverables, advise when things go off track, and suggest improvements. System development management. This role oversees the entire SDLC system development lifecycle. They ensure the right development methodology is used and that the system is built to meet both technical and functional needs. Security officers. They focus on making sure the system is secure, reviewing access controls, data classification, and whether the project complies with company security policies. Information System Security Engineer. This person builds the technical side of security into the system, like encryption, secure coding practices, and configuring systems securely. They work with both the development and security teams. Privacy Officer. Privacy is a growing concern. The Privacy Officer ensures compliance with regulations like GDPR and conducts privacy impact assessments. They make sure data protection is considered at every stage. Senior Management. They give the green light for major decisions and funding. More importantly, they provide ongoing strategic support and keep the project aligned with enterprise goals. IS Auditors. Our role as auditors is to ensure controls are properly designed and embedded. We help guide governance, risk, and compliance. And one important note: if we audit a system later, we shouldn't have played a direct role in building it to stay independent. Let's imagine a data warehouse project. The sponsor from operations sets the vision. The IT-led project manager runs the execution. QA validates results. Security checks that personal data is safe. And the IS auditor monitors risks and ensures controls are in place. In summary, a well-structured project relies on clearly assigned roles that work together, each with their unique focus, but all driving toward the same goal: a successful and secure outcome. Let's walk through a practical example of how different roles contribute to a successful IT project, say, the implementation of an expense management system. Project Steering Committee. This is the top-level decision-making group. In our example, it includes the CFO, head of IT, and operations director. They approve the full project budget, let's say £250,000, review progress at key milestones, and resolve high-level conflicts between departments. Their main goal is to ensure the project aligns with strategic business goals, such as reducing operational costs. Project Sponsor. Here, the CFO acts as the sponsor. The sponsor owns the business case and defines what success looks like, for example, automating 90% of expense approvals within 3 months. They secure funding, sign off on major deliverables, and help the project manager coordinate priorities across departments. Project Manager. This is typically a senior IT project manager. They handle the day-to-day activities, managing timelines, teams, and vendors like SaaS providers. They provide regular updates to both the sponsor and the steering committee and ensure everything stays on track. User management and teams. Representatives from finance and HR act as the voice of the users. They define how the system should work, test the system before go live, and help train staff. Their feedback helps shape a system that truly fits operational needs. Quality Assurance, QA. A QA lead from IT ensures quality throughout. They validate deliverables, review sprint outcomes, and flag any issues with development standards or incomplete work. This ensures we don't sacrifice quality in the rush to meet deadlines. Security Officer, Team Top T. A security analyst reviews everything from data classification to encryption. They check who can access what and make sure audit logs are secure and unalterable. Their job is to ensure the system meets our internal security standards from start to finish. Is Auditor? The IT auditor joins in an advisory role. They help design controls like duplicate detection or segregation of duties and check compliance with internal policies. But since they're involved in development, they won't audit the system later to maintain independence. Recap example. Imagine the expense system is nearly ready. Finance defines expense rules, QA validates the final sprint, security confirms encryption is working, and the project manager pulls it all together. Meanwhile, the steering committee gives final approval before launch. In short, each role plays a critical part from strategy to day-to-day execution, from user input to audit and compliance. When roles are clearly defined and responsibilities are followed, projects are far more likely to succeed in time, on budget, and with the right controls in place. Every project operates within 3 core constraints: budget, time, and deliverables. These must be carefully balanced. If we expand the project scope without adjusting time or budget, delays or cost overruns are almost guaranteed. Likewise, if we try to speed things up too much, we risk compromising quality. To plan effectively, we need to estimate effort and resources, and there are 3 common techniques for this. Analogous estimating. This method uses past projects as a reference. Let's say you built an invoicing system last year. If this year's project is similar, you can use that experience to estimate time and cost. Parametric estimating. This is more data-driven. It uses unit rates like cost per user or time per report to calculate estimates. For example, if it usually takes 2 hours per user account to set up and you need 100 accounts, you can multiply and estimate from there. Bottom-up estimating. This is the most detailed approach. You break the project down into small tasks, estimate each one individually, and add them up. For example, if you're developing a mobile app, you estimate each screen or function separately and total the effort. From an IS auditor's perspective, these estimation methods are important to understand. We look at how they're used to check whether the project plan is realistic, justified, and aligned with business goals. If estimates are inaccurate or not evidence-based, the entire project could be at risk. A project portfolio includes all ongoing projects in the enterprise. It helps with prioritization and resource allocation. A program consists of related projects that support a broader strategic goal. The PMO, Project Management Office, is responsible for defining project standards, supporting documentation, and helping teams follow best practices. It doesn't manage project content directly. For example, an ERP program might include finance, HR, procurement modules. All are managed under the same program manager, sharing scope, schedules, and budget. When setting project objectives, we use the SMART approach, making sure goals are clear, trackable, realistic, aligned with business needs, and time-bound. When planning a project, the project manager should carefully consider to plan at the very beginning of a project. First of all, they need to define the scope. What exactly is the project expected to deliver? Setting clear boundaries helps avoid confusion and delays later on. Then, the manager breaks that scope down into individual tasks. These are all the steps that need to be completed in order to reach the final goal. After identifying the tasks, the next step is to decide on the sequence. Some tasks must be done before others can start. Getting the order right keeps the project moving smoothly. Each task also needs a time estimate. How long will it take? This helps create a realistic project timeline. Next is priority: which tasks are most important or time-sensitive. Knowing this helps with decision-making if there are delays or limited resources. Speaking of resources, the project manager must identify both IT and non-IT support needed. That could mean developers, testers, trainers, or subject matter experts, anyone involved in making the project a success. Budget is another key point. For every task, there will be a cost, whether for people, tools, or services. The manager estimates this in advance. And finally, there's the question of funding. Where will the money come from? It's the manager's job to make sure that the funding sources are identified and that the budget is aligned with available resources. By carefully planning all these areas, the project manager sets a strong foundation for the rest of the project to succeed. To plan any project effectively, we start by breaking down large objectives into smaller, manageable tasks. Once these tasks are defined, we use scheduling and estimation tools to plan the timeline and estimate the required effort. Let's quickly walk through 5 widely used tools. First, Gantt charts. These display tasks on a timeline. You can easily see when each task begins and ends and whether tasks overlap. It gives you a clear, visual picture of how the project is progressing. Second, the Critical Path Method, or CPM. This tool identifies the longest sequence of dependent tasks. If any task on this path is delayed, the entire project will be delayed. That's why monitoring the critical path is essential for keeping the project on track. Third, PERT, the Program Evaluation Review Technique. PERT uses 3 time estimates for each task: best case, expected case, and worst case. It's especially helpful when there's uncertainty in how long tasks might take, giving you a more realistic view of the project's duration. Fourth, Function Point Analysis, FPA. FPA is used to estimate the size and complexity of software projects. It focuses on the functionality delivered to the user rather than technical aspects. This makes it a great tool for estimating effort in large business applications, regardless of the technology used. Fifth, Time box management. This is a technique where software is delivered within a short and fixed time frame using predefined resources. It's commonly used in rapid application development and prototyping. The goal is to deliver key features like important system interfaces quickly while balancing quality and time constraints. Execution is where the project team builds the solution. Monitoring ensures that the work stays on scope, on schedule, and within budget. Effective monitoring involves tracking KPIs, managing changes, and reviewing deliverables at key milestones. Closure confirms that project goals are met, includes postmortems, and involves handing off operations to support teams. For example, after implementing a finance system, the closure includes final reports, documentation transfer, and a review meeting capturing lessons learned and improvement areas. IS auditors play either a preventive role, advising during the project, or a detective role, auditing after implementation. If involved during the project, auditors help validate control implementation, review risk registers, monitor development methodology adherence, ensure compliance with SOD, QA processes, and security requirements. If not involved, they independently audit the system post-go-live. Let's give an example. An IS auditor advises on multi-factor authentication design in a banking platform, but does not participate in user testing, preserving audit independence. Let's make some practices. Question 1 is, which of the following best helps to prioritize project activities and determine the timeline for a project? A Gantt chart. B. Earned value analysis. C. Program evaluation review technique, PERT. D. Function point analysis. Before we jump into the explanation, now is a good time to pause the video and think about your answer before we reveal the correct one. Now, let's briefly go through them. Gantt chart is a great visual tool to track progress and task duration, but it doesn't help with prioritization or complex dependencies. Earned value analysis focuses on monitoring project performance and budget progress. It's useful once the project is underway, but not for initial planning. Function point analysis is used to estimate effort in software development projects by measuring functionality. It's not directly related to task sequencing or timeline planning. PERT, on the other hand, is designed for project scheduling. It uses 3 time estimates, best case, expected case, and worst case for each task. It helps identify task dependencies, evaluate uncertainties, and determine the critical path. That makes it ideal for prioritizing project activities and setting a realistic timeline. So, the correct answer is C, Program Evaluation Review Technique, PERT. Question 2 is, which of the following is a characteristic of time box management? A. Not suitable for prototyping or rapid application development. B. Eliminates the need for a quality process. C. Prevents cost overruns and delivery delays. D. Separate system and user acceptance testing, UAT. Pause the video now and take a moment to prepare your answer. If you're ready, Let's go through it together. Which of the following is a characteristic of time box management? Now, we need to identify the most accurate characteristic. Let's walk through the options. Not suitable for prototyping or rapid application development. This is incorrect. In fact, time box management is especially suitable for prototyping and RAD. It allows delivery of core functionality quickly and iteratively, so this option is the opposite of what's true. Eliminates the need for a quality process. Again, this is incorrect. Even within a short time frame, quality cannot be sacrificed. Timebox projects still require proper testing and quality assurance, just in a focused scope. Prevents cost overruns and delivery delays. This is the correct answer. The main advantage of timeboxing is that it imposes a fixed time and resource limit. Teams must deliver the most critical features within that box. This helps control scope, avoid feature creep, and by design, reduces the risk of running over budget or time. Separate System and User Acceptance Testing, UAT. This is not a defining feature of timebox management. Testing phases may still be integrated depending on the project, but timeboxing doesn't require them to be separated. Question 3 is, an information systems, IS, auditor reviewing a series of completed projects finds that the implemented functionality often exceeded requirements and most of the projects ran significantly over budget. Which of these areas of the organization's project management process is the most likely cause of this issue? A. Project scope management. B. Project time management. C. Project risk management. D. Project procurement management. Now, you can pause the video again if you'd like to take a moment before we continue. All right, let's walk through it together. The situation is, an IS auditor notices that across several projects, functionality exceeded what was originally required, and projects ran significantly over budget. So, we ask, what part of the project management process is most likely responsible? Let's evaluate the options. Project scope management. This is the correct answer. When projects deliver more than what was asked for, what we call scope creep, it usually means scope management has failed. Poor scope control leads to added features, extra work, more time, and of course, higher costs. This is a direct match to the symptoms described. Project time management. While time delays might occur, the issue here isn't just late deliveries, the addition of features beyond original requirements. That points more clearly to a scope issue than a time planning issue. Project risk management. Risk management deals with uncertainties and mitigation plans, but it doesn't directly explain why the functionality exceeded requirements. Project procurement management. Procurement is about acquiring goods and services. It's not related to controlling what gets built inside the project scope.